Hi there, folks. Today we're looking at solving inequalities. And solving inequalities is really no different from solving equations. We're still going to work backwards through order of operations. We're going to undo the operations as we go. So we undo addition and subtraction. We undo multiplication, division. We undo things like parentheses. Or we apply the same techniques that we did before, where we distribute and we combine like terms and then we solve, okay? All that same stuff is going to apply, but there's one little thing that's different, and it's if you multiply or divide each side by a negative, you have to flip the inequality sign. And the reason for that is this. So just a real quick explanation. If I had negative x is greater than 5, if I were to solve this without multiplying or dividing by a negative, okay, I would solve this by doing this. I would like add the x over to the other side, okay? So I'd end up with a 0 over here, and then the x and the 5 would be together. And then I would subtract the 5 from each side. And see, the values I get here when I write this thing, so I get negative 5 is greater than x. The values I get here are the same thing that I would get if I divided each side by a negative 1. But you see, what's happened essentially is I've switched sides. When you look at the original, the alligator is eating the negative x. But when you look at the solution after I've solved by moving stuff around, the alligator is actually eating the negative 5, okay? So the inequality symbol is pointing a different direction. If I were to rewrite this guy in the proper format, I'd write it as x is less than negative 5. And so as you look at these two things, where I started and where I ended, it appears as if the inequality sign has flipped. And so that's kind of the shortcut that we just remember. You know, when we multiply or divide by a negative, we flip the inequality sign. What's really happening is we're switching sides of the equation, okay? So it's kind of this illusion that the inequality sign flips, but that's the way we have to remember it, okay? It would be really silly for us to think about actually moving these things each time and then trying to figure out where the inequality symbol should be facing. The easy way to remember is just you have to remember when you multiply or divide by a negative, you flip the inequality sign. Okay? And it's a result of us just kind of changing sides. And with equations, that didn't matter. You know, when you change sides of an equation, an equal sign is the same no matter which way or which side you're on, all right? But an inequality sign is not. And so we have to just remember this rule that when we multiply or divide by a negative, you have to flip the inequality sign, okay? For example, if I look at something like this guy, if this said 4x equals 12, if this was an equation, I would solve it by undoing the multiplication. You undo the multiplication using division, so I would divide by 4. And whatever I do to one side, I have to do the other side. So I solve it the exact same way I would solve an equation. The only difference is I have an inequality sign, so this is an x, this is a 3, and normally with inequalities, I just leave the sign the way it is. So in this one, I just leave the sign the way it is. I only flip it if I multiply or divide by a negative. And here I divided by a 4. Well, that doesn't change anything. If it had been a negative 4, I would flip it, okay? But that's it, all right? And then the other thing I can do is I can graph this to check the solution, okay? And we did a lot of graphing the other day, all right? So we're not really focused on the graphing right now. But just a refresher on that, remember this would have a closed dot. Sorry, I'll do it on the line. And then greater than, I would shade everything in this direction, okay? If I look at the next one, notice I have pretty much the same example here, but now it's negative 4x. So to solve this one, I'm going to divide each side by a negative 4 this time. So it's almost the same exact example. Here I get a negative 3, but the big difference now is I divided by a negative, so what I have to do is I have to flip the inequality sign. I make it a less than or equal to symbol. Okay, that's the big difference here, all right? I solve things the same way I've always solved them, all right? But if I multiply or divide by negative, I have to flip the inequality symbol, okay? Once again, if I draw a quick sketch of this thing. And see the only difference now, look at this. I've got an equal to condition, but now I'm shading the other way, okay? Again, the thing flips when you multiply or divide by a negative. Notice the graph flips, the inequality flips, okay? If I look at the next one, once again, I'm going to solve this by dividing because I'm multiplying by a negative 5. So to solve this, I divide each side by a negative 5. And again, because I just divided by a negative, I have to flip the inequality sign. So that's x is greater than a negative 7 now, okay? And once again, quick sketch of the graph. I would use an open dot this time, and then greater than is everything to this side. Okay? If I look at the next one, there are two ways to solve this one. If I've got a negative x, it's like a negative 1x. I can't see that one, but I know it's there. It's a negative 1x. So you could think of it as dividing each side by a negative 1, or you could multiply each side by a negative 1. Some students prefer to multiply here. I personally prefer to divide. That feels like it makes more sense to me because it's times negative 1. But over here, negative times a negative is a positive, so it's x. Over here, that's a negative 6. But because I multiplied each side by a negative, I have to flip the inequality sign. Okay? And if I had divided each side by a negative 1, I'd get the same thing. And I have to remember the same thing, which is to flip that inequality sign. Okay? Once again, quick sketch of the graph. This time, because I have an equal to condition, I'm going to use a closed dot. And then greater than, I shade everything above that. Okay? If I look at the next one, I look at where x is here. See, I have a 2x. In order to undo multiplying by a 2, I have to divide each side by a 2. And so over here, I get a negative 2. Over here, I get an x. And some students get fooled by this, and they see this, and they say, oh, I got a negative, so I flip the inequality sign. But what did I actually divide by? That's the real question here. The thing I divided by this time was a positive 2. So the question is, should I flip the inequality sign? And the answer is no, all right? Only if I multiply or divide by a negative. I divided by a positive, so the inequality sign stays the way it is. Okay, it stays like this. But now I might want to rewrite this thing, okay? Because typically I want to write the x first. So make sure the alligator's eating the same thing. It was eating the negative 2 before. I'm going to keep it eating that negative 2. And now I can draw a quick sketch of this thing, okay? Again, just filling in my number line around the value that I need. There's no equal to condition, so I use an open dot. Less than, I shade everything below that value, okay? If I look at the next one, once again, I have a negative 7x. To solve this, I'm going to divide each side by a negative 7. And so this time I get a positive 2. Over here I get an x. But now the thing I divided by was negative, so I have to flip that inequality sign. So I'm going to rewrite that inequality sign like this. But now, once again, I'm going to rewrite this in terms of x. So I put x here. Make sure the alligator's facing the same way. It was eating the 2 before. It's going to keep eating that 2. Okay? And now I draw a quick sketch of the graph. No equal to condition, so I use an open dot. X is less than that. So I shade everything to the left. Okay? If I look at these guys now, a couple more steps added in here. Once again, if this was an equation, if I was looking at 3x plus 11 equals 4, remember I undo addition and subtraction first, then I undo multiplication and division. It's no different here. So I undo the addition first by subtracting 11 from each side. Because remember, I'm working backwards through order of operations. So I get 3x is greater than or equal to, looks like a negative 7. And now from here, and notice the inequality sign didn't change because I didn't multiply or divide by a negative, okay? Only if you multiply or divide by a negative. And so now to undo multiplying by 3, I divide each side by 3. And notice, once again, I divided by a positive, so the inequality sign stays the same. And you could leave that as a negative 7 over 3. I'm going to rewrite it as a mixed number because it'll make it easier to graph. So 3 goes into 7 2 times with 1 left over. And now I'm going to graph this thing. Quick sketch of the graph. Let me take it off to the side. And so again, think about where that is on a number line. If I had something like, negative 2 here and negative 3 here, negative 2 and 1/3 would be right around here. Okay, so right in between these guys. Oh, and it should be a closed dot this time. And then greater than, I'm going to shade everything in this direction. Okay? If I look at the next one, once again, if I'm working backwards sort of operation, so I undo addition and subtraction first. So to undo subtracting a 6, I'm going to add a 6 to each side. Again, the inequality sign stays the same unless I multiply or divide by a negative. And now to undo multiplying by a negative 2, I divide each side by a negative 2. So now I divided by a negative, I have to flip the inequality sign. And I get a negative 8. And once again, I draw a quick sketch of the graph. So again, I only flip that sign if I multiply or divide by a negative. And now no equal to condition, open dot, greater than, so I shade in this direction. Okay? If I look at the next one, again, when we're simplifying and then solving, we want to simplify by doing things like our distributive property. We want to simplify by combining like terms. And then when there's variables on both sides, I have to get them on the same side. So if I look at this one, right away I have some terms I can combine over here, the 7m and the minus m. And so when I combine those, that gives me a 6m over here. And now from here, if I want to solve this thing, I have to get rid of m from one of the sides. So I'm going to come over here and say, hey, I want to get rid of this m. So I'm going to subtract 6m. And what happens is kind of this weird situation. These guys, well, that gives me a 0, so I just have a negative 5. Over here, I just have a 7. And so now I have to ask myself, I got to look at this. This is a weird situation. It says negative 5 is greater than or equal to 7. Well, is that true? Is negative 5 bigger than or equal to 7? Well, hopefully you're looking at that saying, well, no, negative 5 is not bigger than or equal to 7. That's not true. So I put a little slash through it. I say that's not true, which means this is impossible. We say no solution for this one. Okay? And just like when we're solving equations, if you get an equation where all the variables go away, all right, and I get a false statement, we say, hey, this is impossible. It's no solution. Okay? And just like solving equations, if I get a true statement, I would say the answer is all real numbers. Okay? So even that doesn't change when we compare it to solving equations. Okay? If I look at the next one, again, variables on both sides. I've got a 6n on one side, a 3n on the other side. I have to get rid of one of those because I can't have variables in two places. I always get rid of the smaller one, so I'm going to get rid of the 3n. So I do that by subtracting 3n. Whatever I do to one side, I have to do to the other side. Over here, I get a 3n. I still have the minus 1. Over here, I'm just left with the 8. And now working backwards through order of operations, I undo the subtraction first. So I'm going to add the 1 to each side. And now I undo multiplication by dividing. So I divide each side by 3. Once again, the thing I just divided by was a positive. So the inequality sign remains the same. Okay? And now once again, if I graph this thing, draw a quick sketch of the graph. So let's see, I've got a 3 in here. Let's start here. 0, 1, 2, 3, 4. An equal to condition, so a closed dot. Less than, so I shade everything to this side. Okay? Once again, if I look at the next one here, I'm going to do the same thing I would if this was an equation. I'm going to simplify and then solve. So I would simplify by doing my distributive property. So I'm going to distribute the 2. So you have 10 minus 8a is greater than or equal to 10 minus 8a. And you might already notice that I have the same thing on each side, but let's think of it the way we solve equations. I can't have variables on two sides, so I need to get rid of one of those. I've got a negative 8a on one side and negative 8a on the other side. I need to get rid of one of those, so I'm going to add this 8a to each side. And what happens is I get this. I get 10 is greater than or equal to 10. So it's another one of those weird situations. And the thing I need to ask myself in a weird situation is, do I have a true statement? Is 10 greater than or equal to 10? And the answer is yes, it's equal to 10. So one or the other. Is it greater than 10? No. But is it equal to 10? Yes. This is a true statement. So then we say all real numbers. And just like solving equations, when we're solving equations, if the variables disappear, I look at it and say, hey, is this true or false? If it's true, it's all real numbers. If it's false, it's no solution. Okay? If I look at the next one, a little bit easier here, okay? This one's not going to be one of the weird ones this time. So once again, I simplify by using my distributive property. So I distribute the 3. That gives me a 3t plus 3. Don't forget to write down the minus 4t. And now I continue to simplify. I've got those t's on the same side. I combine like terms. So I'm going to add these guys together. So that gives me a negative 1t plus 3 is greater than negative 5. And now from here, I work backwards sort of operations. I undo addition and subtraction first. So I'm going to undo adding the 3 by subtracting the 3. I do the opposite. Once again, the inequality symbol hasn't changed because I didn't multiply or divide by a negative. But now, sorry, I could keep that 1 in there. If I want to undo multiplying by that negative 1, I could divide each side by negative 1. So here I get t, here I get an 8. Now I divide it by a negative. I have to flip the inequality sign. Okay, so it becomes a less than symbol. All right. And then once again, I can draw a quick sketch of this thing. No equal to condition, so I use an open dot. Less than, so I shade everything below that value. Okay? So again, it's the same stuff we've been doing. You know, we're distributing, we're simplifying, that kind of stuff. We're solving the same way we always have, but if you multiply or divide by a negative, you have to flip the inequality sign. And then if I look at something like this guy, it says you have 42 feet of fencing for a vegetable garden. If the garden has to be 12 feet long, what are the possible dimensions for the width? Okay. And the first thing I would always do on a question like this is always draw a picture. It doesn't have to be a good picture. I'm never going to draw a picture that's going to be fantastic. But it said I have a vegetable garden that I want to have that's 12 feet long. And I want to know, well, how big could it be in the other direction? Okay. I have a certain amount of fencing. And so, again, I'm going to draw a picture here. It says I want this thing to be 12 feet long. So that's these two sides. All right. So right away, I can see that I've already used 12 feet on each side. I've already used 24 feet of fencing. I want to know, well, what do I have left for these guys, okay, for the width? And I'll call it W, okay? And so the idea here is when I add up all 4 of these sides, okay, I want to make sure that it doesn't exceed 42 feet because that's all I have to work with here, okay? And so if I add all these together, and let me write it out over here. So I've got a W. I've got a 12, I've got another W, and I have another 12, okay? And I want that to be less than or equal to 42. And see, the reason it has to be less than or equal to 42 is because that's all the fencing I have. If it's too big, I'm going to run out of stuff. I won't have enough fencing to put around my vegetable garden, okay? And so it's set up as an inequality. I'm going to solve this thing. I combine like terms. That's 2W plus 24. And now I solve, okay? I undo addition by subtracting. Let's see, that's going to be an 18. And now I undo multiplication by division. So I get W is less than or equal to 9 feet, okay? So in other words, the width of my garden has to be 9 feet or less, okay? And so if I'd ask the question, you know, what's the biggest the garden could be? You would say, oh, the biggest it could be is 9 feet wide, okay? But maybe that's more garden than I want to take care of, so I can always do less, okay? And that's the idea here between an equation versus inequality. The other way that students solve this one is a lot of times students will do this, okay? They'll say, all right, W plus 24, or sorry, plus 12 plus W plus 12. And they'll say it has to equal 42, okay? And see, this is not necessarily wrong. What's going to happen is you just have to interpret your answer differently. If you work through this, that's 2W plus 24 equals 42. And I want you to understand what you're solving for as you work through this. Notice we do the same thing. We subtract the 24 from each side. We divide by the 2. And here we get W equals 9, okay? And really the big difference here is that we're not interpreting the answer correctly. When we set this up as an equation, that's okay. We get that answer of 9. But think about what you're finding here when you find the 9. This 9 feet right here is showing us the biggest that it could be. We'll rewrite this and say, well, that's the biggest it could be, or it could be less. So it could equal the 9, or it could be less than that. Okay? And so it's okay to solve it as an equation, but you should interpret it then as an inequality. Think about the situation. Okay? And I show that just to show that really it's the same thing. All right? When you solve these, it's the same steps. It's the same way you would solve it as an equation versus an inequality. The only difference is how we interpret that answer. Okay? And when you approach solving inequalities, approach it the same way. Okay? Do the same things that we do when we solve equations, but we have that one little rule of if you multiply or divide by a negative, you have to flip the inequality sign. Okay?